This is a laser beam. That is a mirror. This is laser beam reflected off that mirror. Can concepts of lines and angles explain reflection of laser beam? Let's understand concepts of angles, lines. Let's look at an axiom, a theorem, and concepts of parallel lines. When it comes to angles, we have many types. Let's look at them all, each in detail. Suppose there is a segment AB and there is a segment AC which is exactly perpendicular to AB. This can be constructed using a protractor. It is what is known as a right angle because the angle between them is exactly 90 degrees. Suppose we have two line segments which have angle between them which is less than 90. It's called acute angle. Suppose again we have two line segments between whom we have an angle greater than 90 but less than 180 degrees. It's called obtuse angle. And suppose you take a protractor and try to mark 180 degrees, you will see that you will get a point which is exactly opposite to the 0 degree. Okay, and this will represent a straight line, and this is called a straight angle, and the construction you do will be of that of a straight line. If we have two line segments who have angle greater than 180 degree but less than 360 degrees, it's called reflex angle. Then here's an interesting case. Suppose you have a segment AB, another segment AC, and another segment AD. Angle BAC and angle CAD have the segment AC in common. Therefore, they are called adjacent angles. Okay. Another interesting case is an adjacent angles, but in this case, the sum of angles is 180 degree. Due to this, the non-common sides AB and AD form exactly 180 degree. That is a straight line between the two of them. This is called a linear pair, where the sum of adjacent angles is equal to 180 degree. Consider another interesting case. We have AB segment, another segment CD, both intersecting at O. If we look at angle COB and angle AOD, they are opposite angles north and south. Okay, they are called opposite angles. Similarly, angle COA and angle BOD are opposite angle which are east-west facing. So these are the concepts of angles. We have thoroughly studied, digested, thought about and simplified the concepts for you. So please like, share and subscribe. Let us look at lines. We could have intersecting lines. We could have parallel lines cut by a transversal. We could have multiple parallel lines, all of them cut by a transversal. And from previous classes, we know that the corresponding angles are equal. And also the alternate angles, are what are known as the Z angles, are equal. Same thing applies for the second set of corresponding angles, and same applies for the second set of Z angles or the alternate angles. Let us look at the axiom. It says if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degrees. For example, if we have our segment AB and the ray CD stands on top of it, no matter how you place it, the sum of the angles DCB and DCA is equal to 180 degrees. This is very easy to see if you take a protractor and if you plot AC as the red line and CB as the blue line and CD as the green line. You can see that if the angle is 40 or 80 or 120, where the CD is pointing to, it doesn't matter, but the sum of angles ACD and DCB will always be equal to the angle which AB forms, which will always be equal to 180 degree. So this axiom is sort of experimentally we can prove it. Let's look at the theorem. So if two lines intersect each other, then the vertically opposite angles are equal. So if we have considered two segments AB and CD which intersect at O, we have to prove that the vertically opposite angles, that is COB and AOD, are equal, and the other set of vertical angles, vertically opposite angles, are also equal. So if you note, AOB is a straight line, right? Because it's a straight angle also, so it makes 180 degrees. So if we add COB and COA, you get 180 degrees. Okay. Similarly, COD is also a straight line or a straight angle. Okay. So the sum of COA and AOD is also 180 degrees. So from 2 and 4, we can see that COB plus COA is equal to COA plus AOD. Okay, so now if you cancel off COA from left hand side and right hand side, you will get COB is equal to angle AOD. So we have proved that the north-south opposite angles of COB and AOD are equal. Okay, so to prove the east-west opposite angles are equal, so angle COA is 180 minus AOD, right? And angle BOD is also equal to 180 degree minus AOD, right? Because first time we are considering the line COD, and the second time we are considering the line BOD. Okay, so since both are equal to 180 minus AOD, then we have proved that angle COA is also equal to angle BOD. That means the horizontally opposite angles are also equal. Let's look at parallel lines. So lines which are parallel to the same line are parallel to each other also. This is a theorem we have to prove. For example, let's say we have a line AB, and let's say CD is parallel to AB, okay, and EF is also parallel to AB. Now what we have to do is prove that since CD is parallel to AB and EF is also parallel to AB, we have to prove CD is parallel to EF. Okay, so for that, since AB and CD are parallel, angle GHB is equal to angle HID, okay, because they are corresponding angles. And since AB and EF are parallel, angle GHP is equal to angle IJF because they are also corresponding angles, but for two pairs of different parallel lines, right? So from 2 and 3 we can deduce that HID and IJF are also equal. Okay, since they are equal, you know, it means that CD and EF are also parallel because the corresponding angles are equal. Okay, so this is the proof.